Mars, the red planet, has long been a subject of fascination for scientists and space enthusiasts alike. While its barren landscapes and thin atmosphere might seem inhospitable today, evidence continues to suggest that Mars might have once been a more Earth-like world, with a thicker atmosphere, flowing water, and potentially even life. Recent observations of peculiar formations on Mars, resembling kidney beans, might offer new clues about the planet's habitability in the distant past. These formations, spotted on Mars's northern hemisphere, may look like kidney beans or blobs of chocolate syrup, but they are actually sand dunes covered in carbon dioxide, CO2, frost. Captured by NASA's HiRISE high-resolution imaging science experiment camera aboard the Mars Reconnaissance Orbiter, MRO, these frozen dunes are more than just visually striking. They provide critical insights into the planet's climatic history and the role of greenhouse gases in shaping its environment. Sand dunes on Mars behave much like those on Earth. They migrate slowly across the surface as winds blow sand from one side to the other. However, during the frigid Martian winters, CO2 frost settles on these dunes, freezing them in place. When spring arrives and temperatures rise, the frost sublimates, a process where a solid turns directly into a gas, releasing CO2 back into the atmosphere and allowing the dunes to resume their movement. By studying these dunes and the frost that forms on them, scientists can estimate how much CO2 frost accumulates during Martian winters. This data helps researchers understand the planet's climatic cycles and how these cycles may have influenced the potential for liquid water and, by extension, life. A key factor in determining the accumulation of CO2 frost on Mars is the planet's axial tilt. Similar to Earth, Mars's axis is tilted relative to its orbit around the Sun, causing seasonal variations in temperature. However, Mars's tilt is not as stable as Earth's. While Earth's axial tilt is largely stabilized by the gravitational pull of the Moon, Mars's two small moons, Phobos and Deimos, are too tiny to exert significant stabilizing forces. Through computer simulations, scientists have discovered that Mars's tilt can vary dramatically over time, shifting from almost no tilt to angles exceeding 80 degrees. These changes, which occur over hundreds of millions to billions of years, have profound effects on the planet's climate. When Mars's tilt is extreme, one hemisphere experiences prolonged summers with intense sunlight, causing both CO2 and water ice to sublimate and enter the atmosphere. During these periods, the atmosphere becomes thicker, trapping more heat and increasing surface pressure. This makes it possible for liquid water to exist on the surface, creating conditions that could potentially support life. Billions of years ago, Mars is believed to have been a much warmer and wetter planet. Geological evidence suggests the presence of rivers, lakes, and even oceans. The planet likely had a thick atmosphere, rich in greenhouse gases like CO2, which helped maintain surface temperatures above the freezing point of water. However, Mars's smaller size and weaker gravity meant it was unable to sustain a strong magnetic field. Without this protective shield, solar winds gradually stripped away the atmosphere, leaving Mars the cold and desolate world we see today. The kidney bean dunes offer a unique window into this ancient Mars. By examining the CO2 frost and the timing of its sublimation, scientists can gain insights into past periods when Mars may have had a thicker atmosphere and more hospitable conditions. These frozen formations act as natural archives, preserving a record of climatic changes that could help determine when and where liquid water might have existed. If Mars ever supported life, it likely thrived during these warmer eras. The presence of liquid water is a critical ingredient for life as we know it, and a thicker atmosphere would have provided the necessary surface pressure for water to remain in liquid form. While modern Mars is too hostile for life, with its thin atmosphere, freezing temperatures, and high radiation levels, scientists believe that microbial life might have once existed in its ancient lakes or underground aquifers. NASA's ongoing missions, including the Perseverance rover, aim to uncover evidence of past life on Mars. The rover is currently exploring the Jezero crater, an ancient lakebed that could contain fossilized remains of microbial life. Meanwhile, the MRO's HiRISE camera continues to provide high-resolution images of Martian features, including the mysterious kidney bean dunes, offering new data for researchers to analyze. The study of Mars' tilt and its impact on climate is crucial for understanding the planet's history. During periods of high tilt, the polar regions receive more sunlight, causing ice to sublimate and greenhouse gases to accumulate in the atmosphere. This thickened atmosphere would have raised surface temperatures and created conditions favorable for liquid water. Conversely, during periods of low tilt, the poles remain colder, trapping CO2 and water ice and thinning the atmosphere. Earth's relatively stable tilt has allowed for consistent climatic conditions over millions of years, fostering the development and evolution of life. In contrast, Mars's fluctuating tilt has led to dramatic climatic shifts that could have alternately supported and extinguished life. By modeling these shifts, scientists hope to pinpoint periods when Mars was most likely to have been habitable. The discovery of these frozen dunes and their connection to Mars's climatic history has significant implications for future exploration. Understanding how CO2 and water vapor interact with the atmosphere can help scientists identify regions where liquid water might have persisted long enough to support life. Additionally, these findings can inform the search for subsurface water reservoirs, which could be critical resources for future human missions to Mars. If Mars' climate was indeed warm enough to sustain liquid water in the past, it raises intriguing questions about its potential to support life today. While the surface is inhospitable, underground environments might still harbor microbial life protected from radiation and temperature extremes. The study of Mars's climatic history also serves as a stark reminder of Earth's fragility. While our planet currently enjoys a stable climate and a protective atmosphere, it's not immune to change. The loss of Mars's atmosphere underscores the importance of preserving Earth's environment and mitigating the effects of climate change. The kidney bean-shaped dunes on Mars's northern hemisphere are more than just fascinating formations. They are frozen clues that could unlock the secrets of the planet's past. By studying these dunes and the CO2 frost that binds them, scientists are piecing together a picture of Mars's climatic history. As we continue to explore the red planet, these discoveries remind us of the interconnectedness of planetary systems and the factors that make life possible. Mars may no longer be the vibrant world it once was, but its frozen dunes hold the promise of revealing what might have been and what could still be possible in the search for life beyond Earth.